Okay, so 10.1 is called the three-dimensional coordinate system. So we are going to learn how to plot a 3D point. Hardest part of this is you're plotting it on a 2D surface, right? So there's going to take a lot of visualization in this stuff. This is to identify the point in space, because space is your 3D. You have to introduce a third dimension to the model. So we are having an x-axis, we are having a y-axis, and now we're going to add in a z-axis. The geometry of this three-dimensional model is called solid analytical geometry. So this is where you move into analytical geometry. The good news is we're not going to spend very much time here, okay? But that's what's the difference between the geometry, you know, just two-dimensional geometry, and then analytical is that third dimension. A 3D coordinate system can be constructed by passing a z-axis perpendicular to the x and y-axis at the origin. The figure below shows the positive portion of each coordinate axis. So notice that the x-axis and y-axis are now flat, okay? And you're passing the z through it vertically. So in this little diagram, the x is forward. So this would be the positive part of my x-axis, okay? The y-axis is left and right, and the y is the positive side of it. So this would be the positive of my y's, excuse me. And then the z is vertical, and that's the positive part. So this would be the positive part of my z coordinate. What's hiding from this, which you'll see through like dashed lines, would be the negatives of each one. So the x is running forward and back, the y is running right and left, and the z is running up and down. The names of the planes are based on the two axes that are forming those planes. So the xy plane is called xy plane because it's formed by the x and the y axis. Okay, xz is formed by xz, yz is formed by yz. The positive, in this case, positive x is forward, positive y is right, and positive z is up. So like we'll kind of talk about it in a second, but if you could picture like almost like a Rubik's Cube that has 4 sides instead of the one that has all the 9. If it has 4 sides, that front right corner is what you're looking at right here. Yeah. You will see they'll be labeled, and where the label of the letter is the positive side of it. So that if there was x's back here, this would be the negative x back there. And the negative y would run this way, and the negative z would be below the plane. Isa.
When you're drawing it, do you always draw it like that?
Usually it's drawn like this, but it could actually be rotated all around, which we'll talk about in a little bit. You typically won't have to draw it. You'll usually either already see points on there and you'll give the label of the points, or you'll be plotting it on what I give you. Okay, so the coordinate planes separate the 3D coordinate system into 8 octants. So instead of just quadrants, because it's on a 2-dimensional surface, you've now got space to fill, so they're called octants, and there's 8 of them. The first octant is the one in which all 3 coordinates are positive in the 3D system. So if you actually look at what's there, they're labeled, okay? And this can rotate all around. This case, the first octant is actually back here. That's where all 3 would be positive. So you'd be moving forward, right, and up to get to that positive part. If you rotated that around and then looked at it on like a 2-dimensional surface, it would almost look something like this. So your x is coming forward, your y in this case is going right and left, and the z is going up and down. And if you moved forward, right, and up, then your point could be somewhere like that, something floating in that space. Okay, this is actually, there's a link to this website on the module. This is a 3D grapher. So this you can actually move around a little bit by rotating your axis. So if I were to move this, right, you see that the x is in the front positive, in the back negative, to the right is your positive y, to the left is your negative y, up is your positive z, and down is your negative z. But you can move this in any way you want. So it kind of gives you that 3-dimensional. Typically, your surface will look, God bless you. Let's see if I can get it back. something like that, okay? Where the X is forward for positive, the Y is right for positive, and the Z is up for positive. So if you actually wanted to see what points look like on this, you can actually adjust these. So if I wanted to have a positive X, that means I'm going to go forward. Okay, so let's say I'm going forward 3 places on the X. You see the little dot moves forward. Now let's say I want to move the Y to the right. That's positive, so I can move the Y to the right. Let's say I'm going to go 4 places. It's moving to the right 4 places. And then if I wanted a positive Z, it would move it above, or a negative Z would move it below. So you can kind of get an idea. This is a little bit easier to see it in that 3-dimensional space, okay? But realize the hardest part is that this plane, the way you're looking at it, is actually tilted forward or a little bit to the left even. So your vertical space is not going to be in a line with the tick marks on your Z. They're going to be a little bit tilted. Okay, so this first example says determine which is the point 2, -3, 3 in the coordinate plane below. So your first one is obviously your X, your second one is your Y, your third one is your Z. So from your center, which is here, the first thing you're going to do is move your X, and your X is forward. That means forward along the X axis. So this is 1, 2, and I'm now here. So that's a positive X of 2. Then the Y is -3, which means I'm moving parallel to this line, which means I'm not going to go directly out from 3 and say, okay, there's my point. I'm going to move parallel to that line the same distance I just moved forward, plus 1. So I'm going to go 1, 2, 3, and this is where I'd be for the Y. And then the last thing you're going to do is move up or down. Because the Z is positive, I'm going to move up 1, 2, 3 places, and I'm going to plot my point. So just be careful. This doesn't mean that if I drew this over, it actually looks like it's 2. It's not exact, first of all, because you're tilting that plane forward. Does that make sense? So you're physically taken and tilted that X forward, which makes your point look lower than it's supposed to be. So if I just ask you to plot these points, they're not all going to be exactly the same, okay? If you're using, like you'll see on the homework, it's actually going to ask you to identify one of these points. If I was to do that, I would kind of use the distance here and here, compare those lines, like actually look at those lines and say, okay, the one forward is maybe a 2, and then the one over here is maybe a 1, and then this one down here is maybe a little bit bigger, maybe a 3. So you can actually compare the lengths of the lines to estimate where it's at. So this would have been negative. You moved forward, you moved right, and you moved back. Actually, it would be forward too. This might be a 3. And yeah. So there's just some additional points for you to look at. So on the one on the front, okay, this is, you've moved forward 2 places, you've moved right 2 places, and you've moved down 1, 2, 3 places. So that would be 2, 2, -3. If I asked you to plot this one, this time you're moving back. So you're moving back 2 places. You're going 1, 2, 3, 4, 5, 6 places to the right, and you're going up 2. That's where those coordinate points come from. So again, you're going to see these a couple different ways. One is the points are already on there, and you have to identify which one is which. One is where it's a blank graph, and you have to estimate where it is. And one is like that, where if you had a bunch of points, you have to figure out which one is which. All right, so we're going to plot the points. I'll do the first one with you, and then I'll let you do the other 2. So C is -1, 3, 4, which means from my origin, which is here, I'm going to move back 1. I'm going to move right 3, 1, 2, 3. And I'm going to move up 4, 1, 2, 3, 4. And that would be C. And again, it doesn't have to be exact. You'll actually, like I would say on your test, even give me those little scoops so that I know how many you intended to move. All right, so D is forward 1. So you're moving from your origin forward 1. You're moving right 3, 1, 2, 3. And you're moving up 2, 1, 2. So it'd be somewhere close to there. Again, doesn't have to be exact, but pretty close. You don't want to be like in the wrong quadrant. Yeah.
You don't want to like
So you don't want to come like here looks like it's 3, right? But you're tilting that whole surface. So really here is 3.
Yeah. So like if like you slide, like I like just like drew lines, just like
Like parallel.
Yeah.
That works, except for the Z.
No, yeah, and then I
Yeah.
just did the like a line.
So then just make sure that you realize that you're tilting it forward
Yeah.
to move up your Z. Yeah. Mm-hmm.
How is that equal to 2?
So you're moving from this space, right? So like think about if it was a piece of paper. This is where it's so hard, right? If your plane is here, this is normally flat, so then it would be 2 from here, right? But it's not. That's tilted forward.
Okay.
So you're moving up as long as you're consistent with your distances, it's fine. If you actually went off of this 2 and said that's 2, it's too high, right? Because it's tilted forward. So you want to actually move after you've gotten to the point that you're at. The same, like if you make those little scoops and you're consistent with your little scoops, it should work.
And like, since it's like down there,
Yeah.
would it be like to the origin and then 1? Or that kind of like.
Depends on how forward the scoop is. Because it depends on because you could take this and you can dip it all the way forward. It's not an exact.
So like, when it says 2.
Okay, and then E is 2, so I'm moving forward 2. 3, -1, sorry. I'm going left -1 and then up 4. 1, 2, 3, 4. So again, like if this is on your test and you're plotting that point, it may not be exactly the same as somebody else's, but as long as you've kept the same distances and you're consistent on your distances, it's fine. And you're not like totally in the wrong spot. Obviously it should be above it, but if you go down instead of, it'd be wrong. Questions? Honestly, I think that's the hardest part. It's just like visualizing that stuff. From here on out, it's stuff you already know. We're just adding on a coordinate. So we're going to figure out how to find the distance between 2 3-dimensional points. And it is the same distance formula as before, except that now we add on Z. So it's the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. And then your midpoint formula is also the same as it was before, except a new variable. So x1 plus x2 divided by 2, y1 plus y2 divided by 2, and z1 plus z2 divided by 2. Okay, example 3 says find the distance in the midpoint of the segment between 0, 1, 3, 1, 4, -2. So again, distance is just the distance formula with an added variable. So D would be the square root of, and I can do 1 minus 0 or 0 minus 1 as long as I'm consistent. I'm going to do 1 minus 0 squared plus 4 minus 1 squared plus -2 minus 3 squared. And I get the square root of 1 squared plus 3 squared plus -5 squared. 1 plus 9 plus 25, or the square root of 35. Just like everything else, if that square root could be reduced, you would make sure you would reduce it. Obviously, 35 breaks it down to 5 and 7, which doesn't get reduced. Easy stuff, right? And then midpoint, I'm going to add the 2 x's, divide by 2, add the 2 y's, divide by 2, add the 2 z's, divide by 2. And I get 1/2, 5 halves, and 1/2. All right, so a 3-dimensional circle is a sphere, right? So a sphere with center H, K, J. So now we've got a new variable for the center because we have a Z. And radius r is defined as a set of all points x, y, z such that the distance between those points and the center is r. So distance from my center out to any point on my circle is going to be r, just like in the picture below. And then you can actually, if you wanted to find the equation of the circle, which we're going to, or the sphere, we're going to rotate this a little bit, but it comes from the distance formula. So if I had taken these points, right, any point on my outer edge of the sphere, and then taken the center, the distance should be the same all the way around, and that distance is actually going to equal the radius, right? So that's where the standard form of a sphere comes from. Okay, it is x minus h squared plus y minus k squared plus z minus j squared equals r squared. So just like the circle, except another variable gets added in there. All right, so find the standard equation of the sphere with a center 2, -4, -5, and radius 3. All you got to do is plug it in. So I know it's x minus the h, so it'd be x minus 2 squared plus y minus the k, so y minus the -4 becomes plus 4 squared plus z minus the j, z minus the -5 becomes plus 5 squared equals the radius squared, which is 9. Just got to plug it in and square the radius. Probably not. What I guess more like this. So this one says find the center and the radius of this sphere given by x squared plus y squared plus z squared plus 4x minus 2y plus 8z plus 10 equals 0. How am I going to get that in a standard form? I'm going to complete the square, not once, not twice, but 3 times. Yes, but you guys are so good at this now. So I'm going to group together the x's. Okay, then I'm going to group together the y's. Y squared minus 2y. Then I'm going to group together the z's. And then I'm going to bump the 10 to the other side. And then I want to complete the square for each one. So take the 4, divide it by 2. It's 2 squared. It's 4. Add it here and here. Take the 2, divide it by 2. It's 1 squared. It's 1. Add it here and also here. Take the 8, divide it by 2. It's 4 and square it. That's 16 added to the left and to the right. Factor each set of parentheses, so square root of first, square root of last, sign from middle. Square root of first, square root of last, sign from middle. Square root of first, square root of last, sign from the middle. And then -10 plus 4 is -6, plus 1 is -5, plus 16 is 11. Questions so far? So just be really careful on that process because obviously if you get that wrong, then you're going to get the next step wrong, which is identifying the center and the radius. So I changed the sign on all my coordinates, right? So the center is -2, 1, -4, and the radius is what? Square root of 11. And if it could be simplified, you'd simplify it. If not, you leave it as it is.
Oh, so you have to change the signs?
Yep, because your original equation's minus, right? That's it, folks. Yeah. Yeah.
I like this better.